Hello, good afternoon, and welcome to another Big Data London webinar. Today, we're talking about how to choose data lake, data lakehouse, or data mesh. So I'm Andy Steed, Content Director of Big Data London, and today I'm very pleased to be joined by Kevin Petrie of Eckersley Group. Hi, Kevin.
Hello, Andy. How are you? Good to see you.
Yeah, really good, thank you. Looking forward to this one. And George Hamilton of Chaos Search. So hi, George.
Hello, how are you? Thanks for having me.
So these sessions are designed to be interactive. There's a lot of interest in this one, so please fire in your questions using the question box underneath the screen there, and we'll ask as many as we can to George and Kevin at the end of the session, where we've got a little bit of time allocated for questions. If there's any interruption in service, there shouldn't be, but just in case, I would just hit refresh in the browser and you should jump back in right where you left us. However, without further ado, I'd like to throw it over to our first of the featured presenters. Over to you, Kevin. Thank you.
Excellent. Thank you very much, Andy. So folks, I'm really pleased to have the opportunity to speak with you today. Okay, good. Everyone can see my first slide here. So I guess the first thing I'd say is that I believe "or" is an important word to use here, but maybe "and" as well, because I think there are ways in which the Lakehouse builds on the lake, and both of them can enable a mesh. And so we'll talk about that. A lot of organizations have a lot of things going on in their environments. So in a lot of cases, you can have complementary approaches and architectures here. To quickly introduce myself, Kevin Petrie. I run the research division and advisory services at Eckersley Group. We're a boutique research and consulting firm focused on the data and analytics segment. I've got 25 years in technology, about 15 in data and analytics. I ran a services team for EMC Pivotal in EMEA and also the Americas, and also ran field enablement for Attunity, which is now part of Click. So I love to write, I love to teach and try to explain complex stuff simply, and data analytics is a great domain to try to do that in. So really pleased to have the opportunity to achieve that here. I'm a bookworm, I'm a dad, love outdoor fitness, love to engage with anyone on any of those things. Okay, so I find it's useful to frame any discussion of data analytics by starting at the 10,000 foot view and talking about digital transformation. Digital transformation has been timely for decades. There's never been a more timely period to talk about digital transformation, because in the last 2 years, as we know, there's this incredible acceleration of organizations moving to digital platforms in order to engage their customers in more virtual forums, in order to drive operational efficiency, engage customers, suppliers, partners, employees through new channels, and build new products. So digitization is just creating an incredible amount of business innovation. It can reduce friction, so it can accelerate transactions, accelerate interactions, and decisions. My children, we have 3 boys, have this expectation that whatever you want, you can go to Amazon and you can get it. And that expectation of instant gratification, for better or worse, is getting built into a lot of business models. So this digital transformation creates an incredible amount of data. As an example, when people move to the cloud, IT actually gets more complicated in a lot of ways, because you have far more digital signals getting thrown off from your infrastructure than ever before. So all this data that characterizes all these digital interactions, all these digital operations, has a lot of potential insight, but you need to make sense of it, and you need to avoid drowning in that complexity. So digital transformation is really raising the bar, raising the pressure on enterprises to unlock the value of data at scale, to make sure that data is an asset, is a source of value, rather than a liability. Because you can be darn sure if you don't take proper care of your data and play it to your advantage, your competitor will. So there's a lot of architectural innovation right now. This is one reason I enjoy working with companies like Chaos Search, because they're at the forefront of figuring out how to give people the right architectural elements. And in this discussion, we'll talk about three particular elements that are fundamental building blocks for modern data architectures. There's the cloud object store. So the cloud object store, as we know, classifies multi-structured data objects, maybe unstructured text, video, images, or semi-structured logs or fully structured tables. You're going to classify all this and store it on elastic infrastructure. So S3 buckets, Google storage, Azure storage, these are all ways to bring together these multi-structured data objects. And it's really a very, very common target. Organizations are looking to get as much data as they can within reason to these object stores, because you are getting into a pay by the drip model. You're able to scale up or down as needed based on your business requirements, and you're able to bring in all new types of data compared to the traditional monolithic data warehouse, which is just focused on structured tables. So the second architectural building block is the lightweight index. And so this is where, if you look at traditional indexes like based on Lucene, there can be a lot of overhead in how you organize data for search. If you take new lightweight approaches, and George will be talking about this more, you can organize and search semi-structured data, in particular at scale. This works very well for logs. As I mentioned before, cloud infrastructures throw off a ton of logs that need analysis for performance reasons. So there are new ways to index data, to reduce the transformation processing overhead, and to give you search capabilities, text search capabilities, that'll really help you make sense of a lot of semi-structured data, logs in particular, at scale. The third foundational building block here is the SQL query engine. Now, this is appearing in a lot of different forms, but the idea is that you're taking kind of one of the core actions of a data warehouse, which is running a SQL command and retrieving data to answer a question, to retrieve rows, to figure out your revenue for last quarter, to figure out your pricing for this quarter. All those SQL queries are the heart of business intelligence projects. And it's critical to be able to retrieve that structured data at very low latency and at high throughput. So there are new mechanisms for providing SQL query capabilities outside of the traditional data warehouse. And that's another sort of decoupled building block within these modern architectures. So these three architectural building blocks, the cloud object store, the lightweight index, and the SQL query engine, are improving enterprise access to high volumes of multi-structured data. Great. So we brought you here today to talk about the data lake, the data lakehouse, and the data mesh. All of these, in different ways, make use of these three common building blocks: the object store, the lightweight index, and the SQL query engine. And let's kind of build from the bottom up on this slide. The data lake is the fundamental construct that's now centered on the object store. As we know, data lakes were born with a ton of enthusiasm and fanfare 10, 15 years ago with Hadoop, which was trying to process at efficient batch scale on commodity hardware, different types of multi-structured data. Hadoop withered because it was just too complex to manage. But the fundamental notion of bringing together multi-structured data makes a ton of sense. And so the data lake, the idea of storing all that multi-structured data in its native format, makes a lot of sense. And it makes a lot of sense on the object store. So you've seen this renaissance, this second version of data lakes based on Amazon S3, based on Google Cloud Storage, and based on Azure as well, Azure Blob Storage, to help data science team bring together, integrate a lot of multi-structured data, store it in its native format, and then transform and analyze it. The data lakehouse adds to this, and it adds to this by enabling now BI teams to come in and analyze multi-structured data by applying, for example, SQL query structures. So we'll talk about that. So you can view the data lakehouse, in my view, as kind of a superset of the data lake. Both of those are architectural constructs. The data mesh there's a lot of talk about the data mesh right now, a lot of enthusiasm. I think Zhamak Dehghani has done some real groundbreaking work there. To me, the data mesh is less of an architectural discussion than it is of an organizational approach. I believe it's an organizational approach that helps business domain experts deliver data as a product to data science and BI teams. So you're essentially making, let's say, a finance manager or a data analyst who specializes in a certain business function. You're going to make them the owner of the data, not just the consumer for their own needs, but also the publisher of that data, the transformation, the publication of that data as a product to the rest of the business. That's a fundamental reversal of the notion that you need to centralize everything and have IT run everything. But I think the key point here is that the data lake, the data lakehouse, and the data mesh can be complementary, and the data mesh organizational approach relies on data lake and lakehouse architectures. Okay, so let's dig a little bit more into the data lake. The data lake, to quickly look at the architecture on the left here, as I said, we're basing this on cloud native object stores. We're applying elastic compute resources to that. The compute and the storage are decoupled so that you can scale up compute for bursty workloads, scale it back down, but you don't need to change the object storage underneath. It gives you flexibility and it gives you economic consumption of resources. So this could reside on the cloud. There are ways now to get that separated storage and compute, those cloud-like capabilities with on-premises object stores as well. And the data lake is going to index and or transform these multi-structured data objects and then help data teams search and model them in order to support data science workloads. Machine learning is a very popular example of artificial intelligence that learns from patterns in data, spots patterns, spots anomalies, and helps teach itself how to predict or recommend or classify future outcomes. That's a great example of data science that makes sense on the data lake. The pros of the data lake are that you can ingest semi-structured data, unstructured data in its native format, and then transform it later to meet your specific modeling requirements. So that's important. You're not taking the time up front to transform everything and put it into one structure, one format. Rather, you're remaining more flexible. You're maybe applying metadata tags to different data objects, and then based on what your data science project is later on, figuring out how to transform it for that particular project. So that flexibility, that lack of requirement for upfront transformation is definitely an advantage of the data lake. There's also a con, which is that the data lake in itself is often going to lack the structure you need to query tabular data for business intelligence projects. And so that kind of limits the ability of the data lake to support the BI teams. It's going to help the data science teams, not so much the BI teams in its core form. So the data lake is offering the flexibility for data science, but not the structure needed for BI. Enter the data lakehouse. So the data lakehouse, this is a term that gets used by a few companies. Databricks, Dremio are two examples. And I'm sort of viewing the lakehouse as a term that if we extrapolate from that, it's really kind of a cloud data platform that's merging the constructs of the data warehouse and the data lake, which means fundamentally you've got the object store, and then on top of that, you've got A, the modeling capabilities, but B, the SQL querying capabilities as well. So ideally, within one platform, you can have both support of BI projects and support of data science projects. You can index and transform your data objects. You can update the data objects now. So you can insert, update, delete, change schemas on tabular data, which is a core aspect of those governed data warehouses. You can search and model your data, but also run queries now to support the BI projects. So the pros here are that you you've got some flexibility. You're supporting both data science and BI. You can update the data. You can transform it when you need to. Maybe you want to transform it up front in a data warehouse type approach. Maybe you want to transform it later in a data science type approach. The cons are that the data lakehouse might still lack some of the structure you need for the high performance BI workloads, and it kind of depends. There are some organizations that believe, some vendors that believe, you know what? You need a data warehouse. That's all there is to it. You need the core data warehouse structures. You need all the elaborate star schemas and everything else, because that's the best way to answer the performance requirements for organizations. But the Lakehouse, there is a ton of investment right now in the Lakehouse, because people do want to try to get a one-stop shop. Support the data analysts with BI projects, support the data scientists with data science projects, merge the data lake and the data warehouse, and that's what the data lakehouse is all about. So ideally, you're offering flexibility to support most of your enterprise projects and workloads. Okay, now there's the data mesh. So the data mesh is a really interesting concept. Usually, folks get into an immediate architectural discussion about the data mesh, which is to figure out, okay, how do you sort of acknowledge that you've got these highly distributed environments, you've got data in a silo at the edge here, data in another silo at the in one cloud or another cloud or a data center here. And so you don't necessarily need to consolidate it all, put it all into one place. You don't necessarily need to have IT and data engineers owning all that stuff. Rather, the data mesh says, organizationally, why don't we have the business experts themselves, the creators of the data, become the owners of that data so that they can transform it for other analysts to consume. So in this scenario, you might have a finance manager that typically owns sales for a given sales records for a given region. Now they're going to become responsible not just for doing their own quarterly reports or their own predictive analytics about next quarter's sales. Rather, they're now going to need to perform additional transformations because they own how that data is going to be published and used by other regions, by the rest of the business. And so that's a fundamental job change that the data mesh is premised on. Now, the interesting thing about the data mesh is that it still uses platforms, in my view, such as the data lake and the data lakehouse. It's going to make use of object stores. It's going to make use of data centers, object that include, file systems or data or object stores. The data lake can contribute to the data mesh because it's giving you those object stores, those ability to put all your multi-structured data in one place. You could have your data as a product that gets hosted there. It can also be that the data lakehouse supports the data mesh for similar reasons. But ideally, if you have one owner of the data who's publishing it as a product to BI teams or data science teams, they could do that within a lakehouse. The pros here are that you've got data integrity. Ideally, the data mesh is saying you're entrusting data quality to the experts that know the domain best. The finance managers are best going to understand those sales records, and they're going to make sure that you've got that version of the truth that the rest of the business consumes. Ideally, it's also efficient because you don't necessarily need to put all your data into one place. You could have the regional owner of a data manage that data there and then provide access to the rest of the business. The cons of the data mesh, you've got this skills gap. In my view, the biggest con is that now you're asking the finance manager to become a data engineer, figure out how to do joins and convert data formats and other types of transformation in order to make that data fully consumable by anyone else in the enterprise. Business experts are not data engineers, so they probably need to have data engineers working for them. So you're talking about a real change in the organizational structure to support these new skills requirements of the data owners. There's also could be a misalignment because the data needs of the core business owner are probably not the same as the data needs of the data scientist. And so you got to figure out how to reconcile that, because ideally you've got one data product that the rest of the business is consuming. So key point is that the data mesh relies on data lake and data lakehouse platforms to standardize data delivery. All right, so if we kind of figure out how to wrap this together, we're looking to evaluate new architectural building blocks and approaches. So as leaders of data teams, I think it behooves you to look at these fundamental building blocks, which are new indexing capabilities, new query capabilities that are decoupled from the data warehouse, and the object store, and figure out how to put this into an architecture that works for you. As you do that, think about the data lake, think about maybe expanding it to a lake house, and then if it makes sense, you can figure out how to use those architectural platforms to support a data mesh approach. I think the second guiding principle here would be to find ways to, where possible, consolidate workloads and platforms. There's no question that silos are not fundamentally good. You really don't want multiple versions of the truth. You ideally should reduce data copies by putting all the records for a given business function into one place. So you should still look for ways to consolidate data sets, consolidate workloads, and consolidate platforms. There's no question that type of infrastructure efficiency can save you money and save you a lot of trouble later on. It's obviously not easy to do given the complexity of migrating lots of data, given data gravity, the fact that when you have stuff sitting in one place for a while, you got a lot of applications built on top of it, and given sovereignty requirements. So in our regulatory environment today, certain types of customer data don't want to go across the ocean because they can't. So you need to overcome all that. But to the degree you can consolidate, I think that's all to the better. And then the final point I'd make here is that don't underestimate what a single platform can achieve. We started this discussion, I said, you don't nearly necessarily need to view these three options as either or. I think they can be complementary. I think the data lakehouse can build on the data lake. I think the lakehouse or the lake can support a data mesh. So don't necessarily view one approach as a panacea. Don't overestimate what a single platform can achieve, because the reality is that most organizations will remain distributed and hybrid and heterogeneous, and the more you can reduce it over time, the better. But it's hard to jump to that. So the data lakehouse, the data lake, and the mesh offer some pretty compelling opportunities to modernize data delivery, and I think it makes sense to start to evaluate those options. All right, so I'm going to hand over to George, and he can talk about what some of these trade-offs and options look like in terms of a real platform from Chaos Search.
Oh, thanks, Kevin. I think that was a really good primer on the different approaches, and I totally agree. Right, this is not an either-or thing. I think it's a lot of customers trying to evaluate what is the best architectural approach for my particular situation, right? And it starts because of the problems that we kind of face today. And I years ago, to give you a little bit of background, I've been in the industry probably about as long as Kevin has. I'm also an outdoor nut and read a lot of books. I actually spent time at EMC and going back 8 to 10 years ago, and I managed the object storage. I was the product marketing for their object storage business, which is what kind of attracted me to come to Chaos Search to see how they activate object storage for analytics use cases. And as much as we did, maybe going back a few more years, we were cloud washing everything. At that point in time, when I was at EMC, we were lake washing everything. All of a sudden, all the storage platforms we had to fit into a data lake narrative. And you remember back in data lakes kind of got a bad rap after that, right? Because they were based on Hadoop, and you could get the data in with some work, but getting any insights out was really difficult. The promise was, as shown here, right, is create the single repository for all of your data. And be able to efficiently manage that growth by having it in a single cost-effective platform, and then be able to get insights out of it very, very quickly. But that really quickly devolved into a swamp, right? With all these different data silos, and then growth, the variety, the 3 V's of variety, volume, velocity, really exceeded the capabilities of the infrastructure. and of the skills of the people to manage it. And even today with, the Lucene index can't keep up with the growth in data. And that's the backbone index for a lot of analytics solutions today. And it just becomes brittle at scale. And then you end up with these gaps in access. You don't have the time to insights that you need. You have a bunch of data, but you have no information. You have no insights. That's kind of where we've ended up. And so today's lake architectures, I'm using Amazon as an example here, and this is not any kind of critique. This is just kind of a representation of how people kind of perceive how they architect their data lake today and how it's used, and some of the deficiencies in that approach. And part of it is this: you have a ton of data movement. We have movement from the lake out to other analytics platforms, obviously, to move it into the data warehouse or to other database systems to do. And so you're creating multiple copies of data, or you're creating whole new data sets and expanding how much data you have to manage. It makes compliance more challenging. And there's just a lot of work that has to happen to get that data from the lake and get it into a format for these different analytics tools. And that's why we have these different approaches of Mesh and Lakehouse and et cetera that are trying to address this issue. But not only inside out movement, but you also have movement outside in. So once we've processed that data, we're pushing it back into the lake and growing the size of the data lake with even more data that's been formatted from those systems. And in addition to that, you also have movement going around the different systems that are attached to the lake. So today's lake architecture really still requires a lot of data movement and prep to get the insights that different business users need for different data sets. And so whether we're talking lakehouse, warehouse, mesh, I think it's better to take a step back and just think about what is the problem that you're really trying to solve here, and what would be the best approach for it. And the two things we're really trying to do, right, is just to eliminate that complexity, to try and address the challenges that come from having these very expensive and siloed analytics solutions and multiple disparate sets of data and multiple copies of data. And we at Chaos Search, we commissioned a survey, and we just got the results back, and a report will be coming soon that we'll write about. And it was interesting to me that of these IT respondents, I think it was greater than 50% of them said they have 4 or more copies of their data, which was, I knew that people had a lot of copies of their data, but to say 50% have 4 or more copies of the data was like, wow, that's a lot of compliance headache. That's a lot of storage you're paying for. That's driving your costs up. That's hard to control and to control access to. And then the second thing is not only kind of eliminating that complexity and trying to break down some of the silos, but also giving users the power. Kind of like this gets to the point, Kevin, you've talked and written about this, right? Data democratization, right? And being able to put the power in the hands of the users for whatever they need, whether it's log analytics, whether they're running SQL queries, BI workloads, and be able to do that concurrently and do it directly on the cloud object storage, because that's the most resilient, reliable, lowest cost storage, and be able to do that without having to all this data pipelines and all this transformation and all the data movement. So just trying to anchor what the real problems are we're trying to solve with whatever approach. This is what it comes down to: eliminating that complexity so that your data teams, which are some of your most expensive and valuable resources, can be doing more valuable things than managing pipelines, and then getting users the ability to query and ask questions of the data easily without all that work. So what really makes a modern data lake architecture? I kind of talked a little bit about the lake washing we did years ago and the Hadoop-based swamps that we used to have. Today, of course, with the advent of cloud storage technology, you can actually build a more modern data lake architecture, and it really should have these 4 pillars. And first is just the ability to easily ingest the data and put all the data into your cloud object storage. And then secondly, and Kevin, you talked about this earlier in your slides, right, is the value of the index. And that is being able to create a highly compressed, yet lossless, single unified representation of all of your data that stays in your cloud object storage. And then by virtue of that index, making it performant for multiple analytics use cases. And then thirdly, is to get to the point of avoiding all of this transformation and data movement, is being able to virtually prep that data in the cloud object storage for different analytics use cases without having to move that data. So it's really about virtualizing the prep, the transformation of that data, and then using open API so that the data consumers can use whatever tool they want to be able to query that data. So virtually prep it, and then open APIs so that the consumers of that data can use whatever tools that they already are comfortable with for log analytics, operational BI, SQL queries, and building their dashboards, and also doing monitoring and alerting. And the data lake really is a big driver of the data mesh, as you already alluded to, Kevin, right? And it's a powerful enabler of a data mesh. And I think the philosophically what the mesh is saying is that it concedes the point that data will always be distributed. And really, and it's really trying to say there has to be better connective tissue. And that's the argument. But I'd like to the last point on your slides, right, is that you kind of make the recommendation, right? Consolidate as much as you can. And I think you also said don't overestimate what a single platform can do.
Yeah.
I would also add don't underestimate what a single platform can do. But I think, as far as the mesh goes, I think there is this balance to strike. Like, and even Chaos Search would concede that you're never going to consolidate all of your data in one big giant bucket. There's always going to be this need. You're going to have a warehouse and other systems, et cetera. But to consolidate as much as you can and to activate the data lake to serve more use cases will make it basically it can serve as a node, an endpoint in your data mesh architecture, but can be one of the largest ones and do the most work to try to at least reduce the complexity of the mesh and reduce the number of nodes within that mesh architecture. And it should make it more efficient and more cost effective. And so the Chaos Search approach is really, and I think just to take a step back as far as like thinking about Lakehouse and the philosophy that Chaos Search has, I think the Lakehouse really comes more of a data warehouse philosophy. It's a little more house than it is lake, generally speaking, because there's still a lot of data transformation that has to happen in the implementation for the Lakehouse to kind of take on more lake-like capabilities. So there's still a lot of work to do in pipelines to make that work. Whereas Chaos Search comes from a data lake philosophy, which is let's bring more of those BI type of workloads to the data lake and to activate the data lake to do that. So the Chaos Search data lake platform, everything stays in your cloud object storage. You pump all of your data into Amazon S3, Google Cloud Storage, and eventually we'll support Azure as well. And the Chaos Search data platform indexes that data. It stays in your cloud object storage. We create, as I mentioned, that unified representation of all of your data, then virtually clean, prep, transform that data, and support multiple analytics use cases via open APIs. So now you've got this more unified data lake architecture with much less data movement, less data prep, and then being able to support multiple analytics use cases and using the same analytics tools that users are comfortable with, that they're used to using. But the scalability and the performance is much greater than the alternatives of trying to do this with, an Elasticsearch stack and a combination of different analytical silos. So it really kind of obviates the need to move a lot of data in, out, and around in a data lake architecture, keeping the data in your data lake, but activating it for these multiple use cases. And so the value of that data lake philosophy, if you look on the left-hand side, this is kind of shows you how complex the architecture can get when you have to pipeline and transform and move data for all these different analytical tools. And, there's endless data prep and movement in this scenario constantly. You need Parquet, multiple partitions. It's very expensive to scale, especially if the users don't have visibility into the underlying structure of the data. You have challenges a lot of times with, particularly with something like Athena with, concurrency. Something and so a lot of companies will try to use Athena to bring SQL queries to their data lake. And that, it's for some ad hoc stuff, some customers will use that. But as soon as they have to scale and do some other things, it's very, very difficult. And there's a lot of prep work to make that work. And in contrast, with Chaos Search, you eliminate all of that headache in the middle by using open APIs, the index that creates that unified representation of all your data. It auto detects the native schemas, and then you can refine that data and prep it for whatever use case that you have. So the difference in the time, the cost, the complexity, with the approach on the left where, the time in between, like whenever you go back and you say, I want to, I want to change how I'm viewing this data. And it can be weeks or months of data prep to respond to users' request for new data or to ask additional questions. And if you can activate the data lake to do this, and you can do all this data prep work virtually, then your access is much more on demand. Now you've kind of empowered your data engineers and your end users to be able to interact with the data, on demand, because there isn't all this hard-coded pipelining that has to take place to get new data sources or to, ask new questions of the data. And so I think I think a good example of this is Blackboard, which is a Chaos Search customer. And this is specifically looking at logs, but they're also looking into additional use cases for their data lake environment. And they were using Amazon's Elasticsearch environment at the time. And so for them, the management just purely for logs was really difficult. So they had multiple environments per region. They had 3 teams that had to manage this. And it just became unstable at that scale. Again, Lucene being the underlying index here for it, it just, the scalability was not there. And so it was a lot of administrative toil. They had to break this up into silos just to be able to scale it and be able to manage it. And that created additional failure points. This was costing them $2 million a year. And at the end of the day, they couldn't, 1 to 3 days of retention at the most was what they could get from that. And they made the move to Chaos Search. And now they have a single pane of glass for this. They have all their environments for storage access. All of this is all in a single managed service now. And so they get all the benefits of having the very durable, reliable cloud object storage with Amazon S3, but they now have a managed platform. They cut their costs more than 50%. So now they went from $2 million a year to less than $1 million a year, while nearly tripling their retention. And they could actually have more retention than that. So if I say to any customer, just for your logs use case, you can triple your retention and cut your costs in half. I think most people would jump at that. And it builds a foundation for them, having activated their data lake this way via this platform, that now they'll also be able to take advantage of the ability to run SQL queries on their data without having to work with something like an Athena or move the data to a data warehouse. So that feature is coming within Chaos Search. And so that's really exciting that, and we were noted in Gartner's report on application query accelerators, which is basically the ability to run SQL queries on your cloud object storage. And so being able to bring together IT data, business reference data, and being able to ask new questions of the data is something that customers like Blackboard and others are really looking forward to being able to do. So whether you want to call it a mesh, a lakehouse, a lake, warehouse, the whole point is we really should be focused on how do we activate all of this data that we have in our data lake for multiple analytics use cases without having to move it around and transform it multiple ways, create multiple copies. And so that's what Chaos Search is trying to do with our philosophy. And with that, Kevin, if there's anything else you'd like to add to that, or we can jump into questions.
George, I thought it was really well put, and I love the point that you made. The data mesh kind of concedes that some data distribution will remain. So we seem to agree that consolidate where you can, figure out how to manage distributed environments where you must. And it is interesting. So I was at Attunity for 5 years, and their business model is having these integration tools to help people consolidate data, ideally into a cloud data warehouse. That was a common target. So they'd buy licenses for 20 or more targets, put a lot of money into consolidating onto that data warehouse, but the old stuff never went away entirely. And so that's kind of the thorny reality of data distribution. but there's no question that putting everything you can into the Cloud Object Store makes a ton of sense. And so the data lake, data lakehouse, and data mesh are good ways to take advantage of that.
Yeah, and certainly I have the bias of activate the data lake as much as you can and consolidate as much as you can.
Yeah.
But it would be a lot of hubris to say that we're just going to eliminate all of these distributed data sources and put everything into your lake. But the point's well taken, right? Try to consolidate as much as you can, because the less connective tissue you have to manage, the more efficient and more cost effective you'll be. And at least try to streamline that as much as you can. And while there's all these different approaches for it, at least from our perspective, we think, if you can, that's why I joined Chaos Search, was I was kind of, when I managed object storage with EMC, it was just relegated to a cold, slow archive, and that's what you do, and just be happy with that. And so when Chaos Search said, no, we can actually transform your object storage into a hot analytical data lake that can be cost performant for analytics queries, I was like, wow, that would be amazing if you can do what you say you do. It's a kind of a tough role for me as a product marketer with Chaos Search, is to get people to believe we can do what we say we do. But when we get customers into a POV and they actually load up data and see what you can actually do with your data lake, I think it opens some eyes, definitely.
Yeah, very cool.
Perfect. Well, I tell you what, I can see some questions coming in, so we'll come to those in a moment. First, though, this session's available on demand almost instantly, actually, after we finish. So if there's any part of Kevin or George's presentation that you want to see again, you can just log straight back in and pause at the relevant slide, or go over the relevant section, what have you. Also, I'd like to bring attention to the attachments that we've got. We've got some great resources from Chaos Search in there that they've sent over that support this presentation. Also, it's Big Data London Day today. It's the day that our registration opened for the main conference. So make sure you click on that. And if you're in London on the 21st, 22nd of September, make sure you register and get yourselves down. We've got a whole theatre on data mesh, for example, so you can carry on your learning, and Chaos Search will be there, and you can come and meet them in person. So I'm just going to move on to some of the questions we've got here. Do keep sending them in, by the way. Awesome. Where to start? Okay. I think I'll go for a Chaos Search specific one to start with. So who owns the data with Chaos Search? So where you to?
Sure. Yeah, that's it's a good question, and Kevin alluded to it too, right? When we talk about data sovereignty and where the data stays is so crucially important. The data stays in the customer's S3 or GCS account. There is no, Chaos Search does not store any of a customer's data. The index that we create, again, is in the customer's account, and we have read-only access to it only. So any concerns about where the data is housed, it is all in your account, not ours, and we only have read-only access to the index once it's indexed.
Perfect. So I was going to, I'll float this to Kevin first. George, you may be able to chip in as well afterwards. It's asking, I suppose, for a data mesh case study. If you share any names of enterprises that have adopted the data mesh approach, I'm guessing with a positive outcome. If you can't name the name, maybe allude to the industry or something. I mean, who's doing it at the moment?
So I cannot provide names. I can say that I've had discussions with Fortune 250 pharmaceuticals firm that was very seriously moving ahead with the data mesh approach, because it acknowledged the reality, as George put it, that data was distributed. They had a lot of different financial indicators, records that were distributed geographically. And so they're dealing with some of their sovereignty requirements. They were dealing with data gravity, stuff that accumulated over years. And they very much wanted to figure out how to have a governance structure, standard approaches, standard templates and formats for that data, so that a given, say, theater manager, the data team working for the head of Singapore, could, in accordance with governed standards, share that data, provide open access to the rest of the enterprise, but it would remain within Singapore. And so that made a lot of sense. And, the fact that this company was in pharmaceuticals, I don't think was as relevant as the fact that they were a global organization that had been around for decades and just had a lot of accumulated processes and data sets and infrastructure that they had to extract new efficiencies from.
Perfect. Is George, anyone Chaos Search working for that you can or can't mention?
Yeah, I can't think off the top of my head any Chaos Search customers that have said that most of our customers, of course, probably have a warehouse of some kind, but whether they've implemented a mesh or not, I don't. Still, mesh seems a bit, I guess, a bit more of an, as Kevin kind of alluded to it, right, an organizational approach that is maybe a bit more academic at the moment, but there is some ways, again, it's really just a way to try to simplify that connective tissue between siloed data sources. So, but I don't think we have any customers that I can name off the top of my head that have actually implemented a mesh along with Chaos Search.
No worries at all. No worries at all. Can you talk a bit more about how data virtualization factors into these platforms? I'll start with you, Kevin. Jump in, George, when you're ready.
Yeah, good question. We didn't talk about data virtualization fundamentally, but so data virtualization provides virtual views of data that's distributed, and it's an important construct because organizations want to figure out if they have a project that's going to straddle data sets that remains in, say, 3 locations. They want to, through pointers, through virtual views, figure out how to take advantage of that. So I think there are definitely scenarios in which data virtualization can contribute to a data mesh strategy and can overlay one or more data lakes, one or more lake houses. It could also make sense if you have the streaming data where you might want to abstract from data in flight, looking at windows of events and so forth, and figure out how to build virtual views that can help you support a lot of real-time use cases. So many of the compelling uses of machine learning these days are more real-time oriented, and I think data virtualization can assist with that as well.
Yeah, from our perspective, to us, it's about being able to virtually prep the data and create virtual views, which doesn't really fit the definition of like pure data virtualization. That's a whole other thing and different definitions. So I kind of avoid the term of data virtualization when we talk about, the Chaos Search's ability to virtually or create virtual views. But that's our everything is in the data lake. Once it's indexed, detect all the native schemas, and now we have a tool that allows you to create virtual views for specific analytics workloads. But that's probably where we kind of fall in data virtualization.
Perfect. And this one I think is to you, George. This is asking about S3 spend, obviously on Amazon. How does what you're doing affect your sort of spend on S3?
Really, so we don't really have much, since the data is staying in your S3. It's still all under your control, and so it may actually reduce your S3 costs in a way, because once the data is indexed, then you could actually even delete the raw data and you would still have access to it via the index. You could offload it to Glacier. So we can actually eliminate a lot of the different tiers of storage that you need, hot, warm, cold storage tiers, where you're constantly moving data amongst the tiers when someone needs to, for some particular analytics usage. But in a way, we help you with your lifecycle management within your S3, then even being able to offload data that's not accessed as frequently to something like a Glacier to reduce your costs while still maintaining instant access to it via the index.
Yeah. And a question is coming about data fabric. So we hear different vendors talking about data fabric, as you mentioned. Lots of talking data lakehouse, which we mentioned explicitly in the title and in the content of this. I'm going to put this to Kevin. Sorry to put you on the spot. I think this question could do with being explained a little bit in terms of, so what do you see as data fabric, and how do you think it comes into the the realm of the things that we've been discussing today?
Yeah, great question. I actually have a colleague that's in the process of researching a report on precisely this topic. I think the data fabric can be an enabler of the data mesh. And to your point, Andy, data fabric is a term like data mesh that gets used in a lot of different contexts. The way I view it is that the data fabric seeks to use a common governance framework and common standard elements across multiple platforms so that you can start to have simpler management of distributed environments. And so the data fabric, obviously sounds a lot like what you might want to do with a data mesh. And it's really kind of an overlay to standardize governance, to standardize data management tasks, to standardize transformation, and so forth within those distributed environments. So data fabric would be a great enabler of the data mesh.
Cool. And it also mentions sort of AI and ML within this question. So how do platforms like we've been talking about deal with AI and ML, or companies who are wanting to kind of leverage the power of those things?
George, I'm happy to take a first swing at that.
Sure.
I think it helps a lot. So AI and ML, ML in particular, in my view, is the most popular, most common form of data science. It's a subset of AI, which broadly I'd characterize in data science. And machine learning, as I mentioned before, helps you spot patterns or breaks in patterns in data. And from that, learn and predict the future, recommend or classify what's going to happen in the future. So that algorithm, that machine learning model, if you layer it on top of the data, in particular, that's within the data lake or the data lakehouse, that's a fantastic way to, if you do it right and you manage it right, realize some new benefits. Because I talked about earlier on, digital transformation has sped up the world. Customers want instant gratification through their smartphones. And so there's a very small window of opportunity to recommend to a customer that they buy product B when they're in the checkout page for product A. There's a small window of time to prevent fraud. There's a small window of time to personalize a web page for a customer who's on your e-commerce site. Those are all ways in which you need sort of a real-time machine learning scenario. And if you have a data lake underneath or a data lakehouse underneath that can give you that fast access to data and accurate access to data, access to accurate data for training the model, then you can start to realize some pretty cool boost to your revenue.
From the chaos perspective, I think that's the vision we're heading towards, because as of today, we support, of course, search analytics and running SQL, and eventually we'll be adding ML capabilities. And so you can envision a future where the data lake, you can use search and machine learning to be able to search for unknowns. You're not sure what you're looking for, looking and identifying patterns and things like that, and then being able to ask new questions of that by being able to actually then bring your BI tools into it to be able to, so you're going from your unknown unknowns to your known unknowns to creating known knowns and being able to create new insights from that feed back into it. So that is an important question, and that's eventually what we envision being able to do, is to using that combination of search and machine learning to identify those patterns, to look for things that you wouldn't normally be looking for, and then being able to apply business intelligence to it to glean an insight that helps the business.
George, I love the way you put that, finding the known unknowns and the unknown unknowns through search. I agree completely.
Yeah. One of the things you touched on, Kevin, in your presentation was about a skill gap when you're sort of democratizing data, and by putting sort of business people in charge of processes perhaps they're not familiar with. How do you solve that? I'd like your insights on this as well, George. But I mean, I guess is it what people call a data literacy issue? I mean, how do you increase the knowledge of data or how to handle data within the business.
Yeah, Andy, great point. So there's two things. One is tools, automated tools that enable self-service, that simplify data engineering tasks, really help. As an example, Fivetran can help you without coding, figure out how to move data from point A to point B. That's critical. There are also ways to automate the transformation tasks, or if you have some SQL capabilities, to create very scalable, modular transformation tasks on data. dbt is a tool like that. So tools that make it easier to deliver and transform data. That's absolutely critical. And there's been a lot of innovation there. The second piece is exactly what you said, data literacy. And data, my colleague at Eckerson Group, Dave Wells, has done some great research on this. And encourage you to check out his blog series. Yeah, there's no question that the more you can make different types of business managers more data savvy, and part of their job description in terms of hiring, in terms of training, in terms of performance and promotion, and everything else, the more you can help them take advantage of data, because you really want to make sure that people are making more data-informed and data-driven decisions. All that requires data literacy, which contributes to the data mesh and closes that skill gap.
Perfect.
I think that's a good answer. And I think whenever I've worked at any company, almost, we put together maturity models, and there's always like 4 phases, right? First you get visibility, because so you know what you don't know. And then you begin to optimize, because now you can see it. Then you begin to automate. And then the last one is where you align your business and IT metrics together, where now a business decision triggers an automated IT response to fulfill that business goal. It's a long curve, especially that automation phase and so we're trying to empower that by giving people the ability to create virtual views of the data so that they can then more quickly respond to requests from the business units to access a new data set or ask a new question. It's still in the hands of the data people to do that, create those virtual views and respond to the business users. Hopefully over time that becomes more automated, where the business user in that 4th phase, right, of business and IT integration, where the business user says, I want this data and I want to ask this question, and it just happens. We're a ways away from doing that, but that is kind of the vision moving forward, of kind of when you activate the data lake platform and be able to create that virtualization, that it should be more automated. And I think there was a stat recently that we saw of another survey that Chaos Search did. I think there's something like, it was like 500,000 open data science, data engineer positions across the US specifically. But we're only churning out about 50,000 people with those degrees and backgrounds out of universities each year. Something's got to give, right? So we need to start doing more and more automation of this, just to free, because those are really expensive, valuable IT resources. And so any CIO, CTO worth his salt is trying to automate as much of the mundane stuff as they can to elevate their role, because it's too easy to job flip right now. You want to keep them happy and engaged in meaningful work. So yeah, automation is going to not take their job away. It's just going to give them the ability to do more important strategic things.
Yeah, very true. I think there's a lot of automated ML platforms like Data Robot, that'll help reduce the burden and the training required and the price of the data scientists to build some of this stuff. There's also a blending of roles, where you look up the job description for a data engineer on LinkedIn. A lot of the skills they're describing are data science skills, or DevOps skills, or observability skills, or ML engineer skills. So the data engineer is getting a lot busier trying to help these people too, as the job lines blur.
Perfect. Well, I think we're going to have to leave it there. We're out of time. It's absolutely flown by. I feel very lucky that we've had 2 such great guests today. So thank you very much, Kevin and George. That's been really great. There's obviously been a big interest at home, because we've had a really good response to the webinar, and lots of people logging on and stuff. I hope everybody has enjoyed it. Once again, after this webinar, don't waste any time. Register for Big Data London straight away, and also check out the other resources we've got for you on those attachments. So I'd just like to thank Kevin and George again for a very, very engaging webinar and their part in it. And thank everyone at home for listening, and we'll see you again soon. So thank you very much.
Awesome. Thank you both.
Thank you. See you soon. Bye-bye.